Before the internet connected billions of people, computers couldn't talk to each other. It sounds strange today, but back in the 1950s and 60s, computers were enormous machines. They could calculate numbers, store information, and solve complex problems. But each computer was basically an island. If you wanted to move information from one computer to another, you couldn't just send it across a network. There was no Wi-Fi, no websites, no Google, no social media, and definitely no YouTube. But then, scientists started asking a crazy question. What if computers could talk to each other? That simple question would eventually change the entire world.
But this question wasn't happening in a peaceful world. The United States and the Soviet Union were locked in a technological race called the Cold War. Then, in 1957, something happened that shocked America. The Soviet Union launched Sputnik, the world's first artificial satellite. Suddenly, the Americans realized something terrifying. The Soviets weren't just competing on Earth, they were reaching space. So in 1958, the United States created ARPA, an organization designed to push advanced technology forward. And among the problems researchers wanted to solve was a fascinating one. How could computers in completely different locations communicate with each other? The answer would eventually become one of the foundations of the internet.
Connecting computers was one problem, but there was another problem nobody could ignore. How do you move a huge amount of information between computers efficiently? Imagine trying to send an entire book through a single road. If that road gets blocked, the whole book stops. Researchers came up with a smarter idea. Break the information into tiny pieces. These pieces became known as packets. Each packet could travel through the network independently, and when they reached the destination, the computer could put them back together. This idea became known as packet switching, and it changed what computer networks could do.
Now, the pieces were starting to come together. Researchers had computers. They had a way to break information into packets. Now they needed a real network to test the idea. And in 1969, ARPANET was born. The first nodes connected 4 research institutions in the United States: UCLA, Stanford Research Institute, UC Santa Barbara, and the University of Utah. Then came one of the most famous moments in internet history. On October 29, 1969, researchers tried to send the word login from UCLA to Stanford. They typed L, then O, and the system crashed. That's right. One of the first messages on the internet was basically low.
ARPANET proved that computers could communicate with each other. But there was still a huge problem. What if different networks wanted to communicate with each other? They needed a common language. That's where TCP/IP comes in. IP helps packets find where they need to go. TCP helps organize those packets and make sure the data arrives correctly. Together, they allow different networks to connect. And on January 1st, 1983, ARPANET officially switched to TCP/IP. This was a massive step toward the internet we know today. Because the internet wasn't one giant network, it was becoming a network of networks.
But the internet still wasn't what you know today. There were connected computers, but using the network wasn't simple for ordinary people. Then, in 1989, a researcher at CERN named Tim Berners-Lee proposed something that would change everything: the World Wide Web. The web introduced a simple way to organize and access information using pages, links, and addresses. He developed the first web browser, web server, and the basic technologies behind the web. And suddenly, information could be connected with a click. The internet had the infrastructure. The web gave people a much easier way to use it.
Now something incredible happened. The internet began moving beyond universities and research laboratories. Commercial internet providers started connecting businesses and homes. Web browsers became easier to use. Search engines helped people find information. Email connected people across countries, and websites began appearing everywhere. By the 1990s, the internet was no longer just an experiment for scientists. It was becoming a global communication system. And then came something even bigger. The internet needed to connect continents, and that's where the story goes: underwater.
Yes, a huge part of the internet's international traffic travels through cables sitting on the ocean floor. These aren't ordinary cables. Inside them are incredibly thin optical fibers. And instead of sending data as electrical signals across the entire ocean, information travels through the fibers as pulses of light. A cable can stretch for thousands of kilometers. Special ships lay these cables across the seabed, connecting continents together. So when you send a message from one continent to another, your data may literally travel beneath the ocean. And that's the crazy part. The internet feels invisible, but underneath all of it is a massive physical machine. Cables, routers, servers, data centers, all working together to make the internet feel instant. And that is how the internet actually works.